We know that arc flash and shock hazards exist in the workplace, but when and how are they identified against an energized electrical work task? Good morning and welcome to the webinar, What is Energized Electrical Work? Are you confused? I'm Anthony, the publisher of Electrical Business Magazine and today's moderator. Before I hand over the mic, let me tell you a little bit about today's speaker. I first met Terry Becker several years ago at an IEEE event in Alberta called the ESTMP. Although we had just met, Terry immediately proceeded to teach me about shock and arc flash and the rampant misinformation involving the two. That's what Terry does. He teaches. He can't help himself. But today, we will all benefit from his drive and passion. Take it away, Terry.
Good morning, and thanks, Anthony, for that wonderful introduction. So I wanted to talk about the history and the status quo a little bit before we talked about what is energized electrical work. I think that's just important. And then sort of close the webinar off with some brief discussion of management of change, which has been very important over the last, again, 12 years that I've been involved in electrical safety, and a bit about the future, where this is taking us in industry in general, and then some closing remarks. So again, history, we have two identified hazards in the workplace. We have shock and arc flash. Unfortunately, we've had one that's been identified, shock, but mismanaged, and then arc flash has occurred. We've had arcing faults and arc flashes, but not at a frequency where it really, unfortunately, had any attention until the last 2 decades. So again, we've been using electrical energy for hundreds of years. There's been probably, again, statistically, thousands and hundreds of thousands of shocks. They just have never been dealt with. So again, we've got challenges with these hazards historically. As far as safe installations as well, 1927 is when the Canadian Electrical Code first published in Canada. Of course, we have the current 2018 edition. So we have had safe installations evolve over, again, our use of electrical energy. And this has contributed to, again, reducing or eliminating shocks and overcurrent protective devices to handle faults, including arcing faults. So again, the safe installations are a requirement that we have needed to establish. So we did have safe use of electrical energy, and those have evolved and have definitely made a significant change and are a key contributor to normal operating conditions so that we don't have workers exposed when we use electrical energy, and in turn when we have workers working on it. There's two rules that are significant. Rule 2304, there's many rules that are significant, but two that have garnered some interest in industry. Rule 2304, disconnection, and Rule 2306, which is the minimum arc flash and shock equipment label that came into the 2006 Canadian Electrical Code. Both of these rules have had some, again, misinformation or myths related to them, which I'll discuss later on in the webinar. So if we get some more history, the American Electrician's Handbook from 1942 to 1960, we taught electrical workers to use their bodies as voltage detectors. So an electrician or other electrical workers have been taught to take a shock, and really that's unfortunate. So it's created, I think, a culture and a behavior that, this hazard is just part of the job. It's a rite of passage, which obviously doesn't make a lot of sense. But every electrical worker, every journeyman electrician, when you ask them, have you been shocked doing your job, they all say yes. So, that's one aspect of this discussion of these two hazards. When you talk about arcing faults and arc flashes, most electricians have not experienced one, thankfully, and have had, no exposure where they've been on a work site. Some have, and so I'm not discounting that. But again, the history here is we've got these two hazards. We haven't effectively identified them, shock specifically, and then arcing and arc flash. As far as the OH&S regulations, there's been evolution here in recent years in Canada specifically. But just to summarize, the OH&S regulations both in the US for OSHA and provincially, territorially, or federally in Canada, there's the general duty clause, which really employers were supposed to identify all workplace hazards, eliminate exposure, and if they couldn't eliminate exposure, reduce risk by applying what's called the hierarchy of risk control methods. So again, OSHA has specific content, in this case on 7E, that's evolved over the years. In Canada, we have had in the last 10 years some electrical safety specific content added to the regulations. Unfortunately, the Canada Label Part 2, it does have electrical safety content, but it's dated to 1990 and it focused on utility workers. So just some slides quick on OSHA. If you do go to their website, you'll see that, you search electrical safety, it will bring up content, and I'm just showing a snapshot again of a summary screen that when I searched for electrical safety, this is what popped up. Also, you will find that OSHA does specifically say that they reference the National Electrical Code and NFPA 70E in their electrical standards. So it's an informal reference, or they'll utilize content. One point of note is that both NFPA 70 and CSA Z462 are not adopted into OSHA or OH&S law in Canada. So Canada Labour Code Part 2, General Duty Clause, as I mentioned, the electrical safety content is way outdated and focuses on utility workers only. Just again, some of the websites. Again, the internet's a wonderful tool. You can find all this information online, and it's readily available. So in Alberta, we have limited direct content on electrical hazards. Alberta has identified the arc flash hazard under Part 18, personal protective equipment, but has not identified shock directly. As far as WorkSafe BC, so I'm just providing a couple of examples. I'm not going to go through every province and territory, but WorkSafe BC does have a complete part 19 on electrical safety, which again is very detailed and very specific. Just as an example, there is a legal requirement for disconnection and lockout, but you have to make sure that you read these rules and explicitly understand, because this is also, it says, yeah, turn it off, but it says if it's not practicable to completely disconnect, and then what it does here, it just pushes to PP when it should actually push to the hierarchy of risk control methods completely. But it is here, it is noted, again, low and high voltage. As far as Manitoba, as another example, it's quite interesting, but they focus right away in Part 38, electrical safety, on safe work procedures. They say there's a legal requirement in Manitoba related to energized electrical work type procedures. So again, I'm just trying to set the context that the history here is we've had this evolution, and specifically in Canada, we are now seeing some of this content that might not have been there 15 or 20 years ago that is now there, and it sort of raises the bar for the employer. Minister of Labour in Ontario, there's limited content directly on arc flash and shock hazards, but it's interesting because the MOL did a couple of electrical safety blitzes that I'm aware of over the last 10 years. So they focused on electrical safety, the regulations. Also, there has been some focus from the Electrical Safety Authority in Ontario on the electrical hazards as well. So the other element of this discussion of history that is helpful when you're reviewing the topic of when these hazards exist in the workplace and when you do a risk assessment is the electrical incident statistics that are available. So again, just briefly, again, back to the regulator, there are statistics available. You have to find them on, again, the government's website. For Alberta, as example, there's some stats I'll just briefly show you. Ontario, the Minister of Labour through the Electrical Safety Authority. I'll show you a couple slides on that. In the US, the NFPA published a consolidated report of electrical incident statistics in 2015. So just this is from Alberta Municipal Affairs data for 2017. What's interesting here is you'll see a lot of information on shock, and I was surprised when I loaded this. It does show an arc flash incident. If you look at the middle of the page on the left, it does say an electrician was working on live disconnect when an arc flash occurred and the fuse disconnect. This resulted in a fire inside a splitter located below the disconnect. The electrician was transported to the hospital by EMS. So arcing faults and arc flashes are occurring, they just aren't occurring at the frequency of shocks and ultimately, unfortunately, fatal electrical injuries, electrocution. So a couple of graphs, overhead power line contacts. Again, unfortunately, the trend is still not necessarily going in the right direction, depending on the province or even nationally in Canada or in the US or globally. Right, so globally, we are having a high frequency of shocks and unfortunately, a lot of electrocutions due to overhead power line exposure, again, intentionally with workers being in proximity when they shouldn't be, or heavy equipment being in proximity within the limits of approach and making contact or getting too close. So again, statistically, shocks and electrocutions are occurring at a high frequency still. The next slide here is the Electrical Safety Authority. They've had their electrical safety report from 2001, and the latest report I have on the screen, the next screen will be 2017. So shock and electrocution statistics initially reported, there wasn't a lot of information on arc flashes at all. Obviously, electrical fires were reported out quite frequently as well. So fires related to electrical equipment, but the reporting of arc flashes and burns to workers were just not evident in these reports. And as I said, it's starting to show up. So this is the latest 2017 ESA electrical safety report. Again, statistically, high shock and electrocution frequency. Really good information in this report now. It breaks it down, lots of graphical content. Bottom left, fatalities and critical injuries by probable cause, 2000-2009, in proper procedure, right? 68.9%. Interesting. Lack of maintenance, 1.6. Aging, 1.6. Poor design, 1.6. System failure, 1.6. Unknown, 13.1. Equipment failure, 1.6. Faulty equipment, 4.9. Human error, 4.9. So in proper procedure, again, what's the detail? What does that mean? Right. So again, you can mine the data and try and sort out, where we need to focus our attention. And my opinion is, of the two hazards, we do need to pay more attention to the electric shock hazard, because every worker on a workplace is exposed to shock. Not every worker on a workplace is exposed to arc flash. Here's the NFPA report. Again, all this information is available publicly on the internet as well. So this report's downloadable. It took statistics from multiple sources in the US, put them into one report. What I've highlighted, that they do have a 20-year stat of 5,567 fatal injuries from electrical incidents. 99% of those were electrocution. So statistically, there's one electrocution occurring right now in the US. And as far as arc flashes and arc flash injuries leading to fatal injury, there might be 1 or 2 a year in the US. So again, just putting into context the two hazards with again, incident statistics and then fatality related data. There's no specific data on physical trauma injury due to arc blast pressure. And as far as I can tell, there's no fatalities occurring due to physical trauma from arc blast pressure. And this is important when we do a risk assessment and we look at potential injury or damage to health, and we look at the arc blast hazard, which is one of the myths and misinformation that's been occurring in the last 10 years about arc flashes, specifically, the arc blast secondary effect on the worker. So status quo, when is a worker exposed to electrical hazards? And to me, this has always been about the job assigned to workers and then the discrete work tasks. And a company would have a workflow, like some form of a work order system, formal or informal. Workers that do maintenance are assigned work. There's supervision, there's direction. Again, those work tasks are discrete work tasks under a job. So the motor's not running. I may have to open up a hinge door. I would be doing voltage measurements at possibly both AC and DC. And the worker needs to identify if they're exposed to arc flash and shock hazards. Complete a risk assessment procedure. Now, this is the context of Z462 and 70E, and with respect to, again, the status quo, because we've had Z462 in Canada now for over 9 years, and 70's been in the US for a long time, but the latest edition of both those standards would require a risk assessment procedure and individual shock and arc flash risk assessments, and then determine additional protective measures to reduce risk, boundaries, PP tools and equipment, and work practices, and apply ultimately the hierarchy of risk controls to reduce risk. So I'm saying this is the status quo. This is where we should have matured in industry related to, again, a qualified electrical worker, journeyman electrician, overhead door and crane mechanic, cathodic protection tech. These are all, again, qualified electrical workers. This should be the status quo for workflow, but we're still not there in industry. This is still not, again, this simple stepped workflow here is still not what's being practiced consistently across Canada, the US, and internationally for sure. So going again, sort of, backwards here before we go forwards, but the status quo is we should have the shock hazard well understood. We should. And so again, a source of possible injury or damage to health associated with current flow through the body caused by contact with or approach to energized electrical conductors and circuit parts. Again, small amounts of current will cause pain and can cause a fatal injury with heart fibrillation. And again, identifying the shock status quo, this, in my opinion, should be well understood. There's been a lot of training, a lot of information. Again, again, it should be well understood, and workers should not say that they don't know what an electric shock hazard is. Again, the shock hazard, as far as once the worker is exposed to it and currents flowing through the body, it is path and amount of time that the current flows through the body will impact the result of the shock. So when specifically is a worker exposed to shock? Again, work task description, exposed conductors or circuit parts, inadvertent movement risk, direct contact, or proximity, right? So again, we don't have to make contact. If we got close enough to high voltage overhead power lines, we can get a shock and a fatal electrocution. The key is exposed conductors and circuit parts, again, and the worker in this case for low voltage going into the electrical equipment, right? High voltage workers, utility workers, they do live line work, but I think the trend is to move away from that if possible. Most of their work is live line tools, hot stick work. So again, low voltage, high voltage, exposed conductors and circuit parts, different workers, different qualification training, different procedures, different techniques, different application of PP tools and equipment when we apply the risk control methods to reduce risk. So working within proximity to exposed overhead power lines and conductors is a multitude of different workers, non-electrical workers, digging again and exposing energized cables, right, inadvertently, right, using portable cord and plug connected electrical equipment extension cords. That's a whole non-electrical worker discussion. We haven't done a very effective job in industry with the non-electrical workers and shocks related to using that equipment. And again, after that, what's the maximum exposure voltage? What's the maximum voltage on this electrical equipment and the conductors and circuit parts that are exposed? Just another little status quo. The Technical Safety BC, which used to be the BC Safety Authority, put a lot of focus on the electric shock hazard last fall. They took statistics that they had, did a report, and I would ask you to check this out on their website. And again, they identified some factors related to electrical shock, a different approach. Again, lots of good information out there to help us understand, what's occurring in industry. In this case, why our work is getting shocked. And then what are we going to do about it in industry? The arc flash hazard, again, should be well identified. Again, lots of training happening. So again, a source of possible injury or damage to health associated with a release of energy caused by an electric arc. And what I've underlined is this definition's from 70 in Z462. I've underlined in the note that an arc flash incident is not likely to occur under normal operating conditions when enclosed energized equipment has been properly installed and maintained. That's really important, but it is a subjective determination of arcing fault probability and what is normal operating conditions. And lastly, a table was added in the last two editions of 70 year Z462, Table 1 30.5C and 70E, or Z462 Table 2, that is a work task list that is very helpful for users of the standard when you're completing an arc flash risk assessment, but it does require assessment of condition of maintenance, and then the table indicates whether the likelihood of occurrence of an arcing fault and an arc flash is yes or no. So again, it is subjective determination based on risk related condition of maintenance, identifying when an arc flash hazard exists against a defined work task. So again, this is sort of the status quo out there. We've had the latest edition of 70 in Z462 now for almost 2 years, and workers should have been trained on the latest edition, and employers should have adapted this information into their electrical safety programs and into the workflow that they apply with their workers and the context of identifying and then moving through an arc flash and shock risk assessment to determine additional protective measures. So another slide on arc flash, it's a probabilistic incident. Abnormal condition required an arcing fault. And again, the abnormal condition could be by worker interaction or without worker interaction. And again, when can an arcing fault occur? Right now, the threshold is 208 volt 3-phase, and dependent on the fault current, we could have a sustainable arcing fault in arc flash. And for DC, 125 volts DC, again, depending on the actual electrical equipment that voltage exists on. Arcing fault is ionization of air. We get an arcing fault, there's impedance, and we'll have a lower fault current because of that. This is some important information with respect to when we're determining the PP that we need. And again, the effects are a thermal energy release called incident energy, UVR light, arc blast pressure, noise, molten metal, toxic vapor. So the first poll question. So I'll defer to Anthony to put the first poll question up on the screen. And if you could take again a few seconds to answer this question: does your company have arc flash suits with an arc thermal performance value greater than 40 calories per centimeter squared ATPV? So we have 67% saying no, 30% saying yes. So again, most companies have only 40 cal suits. first poll question. And that poll question was strategic with respect to some of the information I'm going to present later about the myths and misinformation about doing energized electrical work. So arc blast pressure, just a slide if you haven't seen this before, because when I do show this, people will have never seen this graph before. So arc blast pressure correlates to arcing fault current, not incident energy. So this is what I call the 40 calories per centimeter squared myth, that work has to stop because it's dangerous or the risk is too high due to blast pressure, which is again completely wrong. So this graph advises you that the distance away from the arcing fault and the fault, that's the arcing fault current and Ka shown on the graph, then correlates to the theoretical pressure released from an arc flash in pounds per square foot. All right, so its available fault current is less than bolted fault current. Again, I emphasize there's no documented evidence of fatalities to arc blast pressure and limited to any information on physical trauma, right? So when we do a risk assessment, the inherent and residual risk as far as potential injury or damage to health is most likely and should be considered as a repairable injury due to blast. This is Dr. Ralph Lee's research from the late 1980s. It's also available and documented in the old IEEE Yellow Book or the 3000.7 series IEEE standards now. So identify when you're exposed to arc flash. Again, a little more clarity here. I mentioned it just earlier, but determine the work task description again. We have the two new tables available in 7DE or Z462. So you need to do an arc flash risk assessment. I also wanted to say that the arc flash risk assessment in the latest editions is also a true risk assessment. We have to identify the hazards, assess the risk, and determine the hierarchy of risk control methods to apply against the risk to reduce the risk so the residual risk is as low as reasonably practicable. So again, look to the right article or clause in Z462 and make sure you're clear on what an arc flash risk assessment is and what's required to be completed. So again, work task, let's say voltage measurement, 480 volts. Yep, at that voltage, we can sustain an arcing fault and arc flash. The worker's hands are going to go in and interact, but there's actually multiple discrete work tasks related to that job. We would go to CSA Z462 table 2. We would find the work task description, and then based on condition of maintenance, it'll indicate the like of occurrence of an arcing fault and arc flash as yes or no. So that's now the starting point as you go through the actual arc flash risk assessment would be to reference this table as part of the process. So as far as the work tasks, the qualified electrical worker performs, interaction is the highest related probability of occurrence. Abnormal equipment condition and arcing fault can occur with no interaction as well. No arcing fault, no arc flash. This is a voltage dependent hazard, both AC and DC, to sustain the arcing fault and convert it to an arc flash or create the arc flash. Other factors are change of state of the equipment and abnormal conditions create an arcing fault and an arc flash. Additional protective measures are determined, as I indicated. Incident energy analysis study or the arc flash PP category method can be used to determine arc flash PPE, the arc flash boundary. And then the worker needs to understand what the working distance is and maintain that distance to their face and torso when they're doing the work task that can expose them to an arc flash. And again, the arc flash boundary is calculated or determined where the incident energy would be 1.2 calories per centimeter squared. And if you're outside the arc flash boundary, we don't need arc flash PP to be worn. So again, arc flash risk assessment, right? It's a process, 3 steps. Again, we can use table 2 or table 135.c for NFPA 70 in that process with the work task list that's there. Again, risk assessment is a 3-step process. Next poll question. So I'll get Anthony to bring up the poll question. Do you believe your company completes adequate electrical equipment maintenance? Again, if you're on this webinar, there it's popped up. And if you could answer again in the next few seconds. Again, do you believe your company performs adequate electrical equipment maintenance? If you work for a company that owns the equipment, or in general, based on your experience, do you think industry is completing adequate electrical equipment maintenance, yes or no? Interesting, almost 50% says yes and no. That's actually good news. That actually really is good news that many believe that they are doing adequate maintenance, and that's encouraging. And I'm glad that actually is the poll result that came back. So status quo, just to finish off the arc flash discussion, abnormal conditions that can lead to an arcing fault. We don't have safe installations. We have the worker interacting. Again, we have to qualify. The worker's in an abnormal state because they're not qualified, they're not competent. Human error, and really human error was propped up in 70 and Z462 in the risk assessment procedure content, and uniquely identified. If we have to say, we have the qualified and competent worker, but human error is a different issue. Obviously, condition of maintenance is another abnormal condition that could increase the probability or the likely occurrence of an arcing fault, an arc flash, or even a shock risk exposure. Not operating the equipment to manufacturer specification, contamination of the electrical equipment, rodent intrusion, over voltage, and damages to insulation. So this is just a list of, again, abnormal conditions where we have a change in state and the likelihood of occurrence can increase. So status quo, Z462 and 70E, I just shown, on the screen, covers for the last 4 editions. And really in 2015 and 2018 is when we saw a significant change in the standards, moving to risk-based content. And the latest editions are 100% risk assessment-based standards, which aligns with occupational health and safety. Again, 4th edition, work task-based, 100% risk assessment-based, not adopted into OH&S law in Canada or 70 in the US. My belief is the OH&S officer would reference it, though. In incident investigations, there's enough awareness in their departments and in industry. So again, 70 first published in 1979, Z462 really first published and was available January 2009. These are technically harmonized still. Again, as far as scope, unfortunately, there's some historical exemptions, which in my opinion shouldn't be there, but they are. So utility, telecom, railways, marine, and mining. But in Canada, mining wanted to be included. And so in Canada, we removed their exemption from Z462. So again, these standards are, again, industry accepted across Canada and US. They will help you identify arc flash and shock hazards. The content is definitions, general requirements, establishing a likely safe work condition, working energized, electrical equipment maintenance. There's a whole clause or chapter on that, special equipment, and the annexes. So briefly, again, a summary of the status quo. This should be known in industry. There's been enough training, right? Again, what these standards contain and what's required. So employer-employee relationship, elimination is the priority, but energized electrical work is allowed. It is allowed, but you have to follow the policy and practice requirements that would be associated with it. An electrical safety program is mandatory and appears right at the front of these standards. And I still believe industry doesn't have electrical safety programs developed, or they're not compliant. There's a mandatory risk assessment procedure in the latest editions. Hierarchy of risk control methods is now mandatory. It was moved from a note into the chapter, into the article or the clause. Human error was identified and propped up in the latest editions. Job safety planning is now a mandatory requirement that shall be documented by the qualified person, and training is still every 3 years. Here's the hierarchy of risk control methods. Again, 6 of them, and again, top down, not bottom up. Most effective: elimination, substitution, engineering safety by design, warning signs and barricading, administrative controls, training and procedures, and PP. So really, when you do a risk assessment, I advise that you apply all 6 and you apply them at the same time. You do one iteration, apply all the controls you can to achieve an acceptable residual risk of low or medium risk if we used 3 levels of risk. Next poll question. So I'll get Anthony to bring this up. Does your company have a compliant electrical safety program developed and implemented? Again, and if you're someone on the phone that's involved in, on the webinar that's involved in the industry, do you see electrical safety programs developed and are they implemented? Do you believe they're compliant? So again, we'll wait a few seconds for responses. 50-50. Interesting. Again, very interesting. So I'm glad to see that as well, because I do believe that electrical safety programs that are developed out there aren't compliant. They don't have a complete framework. They're missing content, and the context maybe hasn't been established correctly. We could talk about that in a lot more detail as well. So back to just closing off the status quo about Z462 and 70, that they should be well understood in industry. They require incident investigations. They require electrical safety auditing in your electrical safety program. Separate lockout program should be implemented and audited. Qualified person, arc flash and shock training, emergency release of a shock victim training, test instruments, portable cord and plug connected electrical equipment and GFCIs. It's all there. You cannot get around what's in these standards. They are very detailed, they've matured, and lots of content that industry should be aware of. Again, de-energizing is a priority. A lockout program procedure should be in place. Establishing an electrically safe work condition is a key concept in 70 and Z462, and I still think that that key concept isn't used effectively as a procedure. And again, training's provided to the qualified electrical worker. They get these concepts, trained to them, but if you don't have the electrical safety program with the policies and practices, then they won't necessarily follow up and actually use the training when they are doing energized electrical work. Justification for energized electrical work is required. The energized electrical work permit requirement is quite clear in my opinion, but what I see in industry, it is not clear. I see a lot of, again, misinformation about the energized electrical work permit. Normal operating condition is defined as well. And again, we have the shock risk assessment and the arc flash risk assessment in the 2018 editions, which are both true risk assessments requiring 3 steps. Again, identify the hazard, potential injury or damage to health, and the likelihood of occurrence determined. Determine what risk control methods are required to reduce risk. So again, the shock risk and arc flash risk assessments, that's an example of a detailed arc flash and shock warning equipment label. I have a lot of concerns too that unfortunately over the last 10 years with the incident energy analysis studies completed, there's a lot of non-compliant labels that are out there, but if the qualified electrical workers trained properly, they would identify these labels, bring them to the attention of their supervisor, and we can get that information sorted out too. Again, the new table 2 that I indicated for the arc flash risk assessment specifically with the work task list, condition of maintenance, like of occurrence of an arcing fault and arc flash, yes or no, but it is a subjective based table. And I'm really encouraging industry to not be conservative when you're determining condition of maintenance. You have to be realistic and reasonable in your determination. So again, arc flash and shock PP, there is no other standard that I'm aware of that has the detail and content on electrical specific PP tools and equipment other than 70 and Z462. Remember, technically harmonized Z462 is based on 70E with a Canadian slant in its format and referencing other Canadian standards. So really at the end of the day, 2 choices for arc rated clothing: an everyday wear shirt and pant coverall, which is now identified against incident energy as 1.2 to 12 calories. The second choice would be greater than 12 calories, which would put you into an arc flash suit. So again, single layer shirt and pant or single layer coverall, arc rated face shield balaclava, canal insert earplugs, CSA approved or approved safety eyewear, approved safety footwear, and then for this, the arc flash suit, again, bib overall, jacket, and arc flash suit hood. So here's some examples of specific PP that's out there. Now, if you haven't seen this, this is the true color gray PP that's out there. Again, this is the status quo. This is all available now. Again, on LED lamps on the face shields. Again, this is a coverall on the left. It's all sort of status quo now. True color gray lenses on the arc flash suits, LED lamps available for the arc flash suits. Again, some old shields, you can see the green tint on the left. So that green tint has now been replaced with a true color gray tint. Again, status quo. Shock PP, we have rubber insulating gloves being purchased. This is all good news, but the status quo is it's great, but we got to make sure workers have the tools to determine when they actually need it in the workplace, and the employer has the policies and practices that back it up. Insulated hand tools, again, test instruments, readily available. Again, status quo. So one last thing is related to status quo. I think there's a couple more slides here. I wanted to say that the IEEE 1584 standard, first published in 2002, has been published in its new edition in November 2018. So that's 16 years later. There is some significant changes in this new edition of IEEE 1584. The studies have proliferated across Canada. From the previous edition, I'm concerned about the report quality, errors and omissions, for instance, the lack of the 2-second guideline being used, conservative determination of the parameters as the inputs to the studies, and then non-compliant and poor quality equipment labels have been issued historically. So I encourage you, if you're the owner of the electrical equipment, that you review your current studies, you review your labeling, and then going forward, as I'm going to highlight, there's been significant changes to the formulas that you have to make sure are reasonably determined and not conservatively determined, or it can have an impact on incident energy going up potentially 200%. So there's an example of what I call a non-compliant label. It has 52 calories. It says that dangerous, exceeds the max safe working level, and work is not recommended. So again, it's putting policy on a label that shouldn't be there. Again, lots of non-compliant labels out there. I encourage you to review your labels going forward. Now, as far as the new IEEE 1584, previously there was only 2 electrode configurations. Now there are now 5 box electrode configurations. So I'm putting focus on one of the key changes, that if you incorrectly determine the box and electrode configuration, the incident energy can go up. So you see an image, it's vertical conductor in a box. This was the actual test apparatus, and then they had vertical open air previously. So this was, again, a box electrode configuration tested for the 2002 formulas. This is one of the new ones though, vertical conductor box barrier. Horizontal conductor box, this is also a new box electrode configuration. What you see here is you see the ends or the tips of the electrodes. And again, what happens is it's an ejected arc that now comes out, and the incident energy will be directly at the worker. So the incident energy will be higher value than the vertical conductor in a box or the vertical conductor box barrier box electrode configuration. All right, so I'm going to try and see if I can get this to run. There we go. So you're going to see ejected arcs. So this is ejected arc, 5,000 frames per second. It's like 3 hoses with high pressure water that are turned on. So remember, this is very fast. This is occurring. This is what our eyes can't see. So what we see is the incident energy will be directed more at the worker in front than being reflected out of the box with the vertical conductor box or vertical conductor box barrier box electrode configuration. And then vertical open air, again, this was previously in the 2002 edition. And then horizontal open air, again, this is a new box electrode configuration, right? So that's just quickly, unfortunately, with the time available, to introduce the new formulas. Again, the challenge here is we got to make sure with the new IEEE 1584 that other parameters too are not conservatively assessed, or we don't spend too much attention on them. We don't have to go out to the site with a ruler or a tape measure and do measurements. We should rely on good engineering practices and the use of typical data. Again, the labels themselves, we want to make sure the label's clear for the worker, that the incident energy is on the load, line side, or bus of the protected device that's indicated on the label. As well, Z462 and NFPA 70E allow the arc flash information to be provided using other methods now. Results tables can be posted by the owner of the electrical equipment. And the 5-year review of the incident energy analysis study is still valid. So I'm telling industry that the formulas have changed. You don't have to panic. You need to spend some time to get the right information about the impact on your existing studies before you proceed with updating your studies. So some compliant labels, or labels that I like. Again, just some quick examples. This one shows an arc flash relay must be on. This one has a maintenance mode switch. So again, these labels, you're going to see, unfortunately, hundreds of different specifications for them in industry right now. As far as moving from the warning signal pan to the danger, technically, when we do a risk assessment, an arc flash chute is available to 140 calories, right? So that's when the label would change from warning to danger. Another poll question. So if I can get Anthony to pull up the poll question, do you believe that operating energized electrical equipment exposes a worker to the arc flash hazard? Now this would be turning it on or off, opening of contactors and opening of circuit breakers and disconnect switches, contactors opening and closing, and motor starters. Wow, 54% belief. So again, this is one of the myths and misinformation that I believe are out there, and it's something that we're going to have to work in industry. That it's a trend that I don't know why we're going this direction. It does relate to the condition of maintenance discussion, but again, operating energized electrical equipment, it doesn't expose a worker to the arc flash hazard unless there's an abnormal condition, right? So again, I encourage you to ensure that you do a risk assessment that's reasonable related to deciding to put arc flash PP on workers that just operate energized electrical equipment. Doors closed, covers on, normal operating conditions. I don't believe we need arc flash PP on workers on a work site. So these are some of the myths and misinformation that relate to our discussion of what is energized electrical work and are you confused? So these are statements or some of the things that I've come across in the last 5 to 10 years. It's against the law to work energized. That's not true. Again, Rule 2304 is being miscommunicated from the Canadian Electrical Code here in Canada, and even the regulations. I gave you some examples. It's not against the law to do energized work. The government would just want the arc flash and shock hazards identified and risk control methods implemented. Testing for absence of voltage doesn't require arc flash or shock PP. That's not true. Until we achieve absence, you assume the voltage is there, arc flash and shock hazards can exist. The next one is our company policy says it's dangerous and no PP exists for energized electrical work greater than 40 calories. Instant energy, arc flash pressure will be extremely high. That's a false statement. One, arc flash PP is available up to 140 calories ATPV, and the arc flash pressure, it doesn't correlate to instant energy. So 40 calories is not a dangerous instant energy level. And I would encourage you that when you do your risk assessments and you look at potential injury and damage to health, that you do consider arc flash suits up to 140 calories. So again, I did show this graph about the blast pressure, trying to again just give evidence that instant energy doesn't correlate to the instant energy doesn't correlate to the blast pressure. So more of the myths. I'm the president of the company. I sent a policy to all the electricians. We don't work energized. We really don't need any of this. That's actually a negligent statement because every journeyman electrician owns a digital multimeter and does energized electrical work. All energized electrical equipment is inherently high likelihood of having an arcing fault and arc flash being created on it. And I believe that's not true. It isn't a true statement. It isn't 100% probability that an arcing fault and arc flash occurs on energized electrical equipment. We have to have an abnormal condition. Arc blast pressure will pulverize you. It's not true. The last one, which was the poll question, operating energized electrical equipment requires full body arc flash be worn at all times. That is not true. This is where, again, risk assessment and the risk assessment procedure identified in Z462 and 70E is a useful tool to get you to understand when a worker is exposed and when they're not exposed to arc flash and or shock. So here's pictures of operating with no PP. Following procedure, stand to the side, look away, standard procedure, use the right hand. The left hand rule is not a legal requirement, it was never, in my opinion, a valid method. Use the right hand, look away, again, for the unlikely probability that you're going to get an arcing fault and arc flash when you switch these disconnect switches or when we're using an HMI on a VFD or a control panel. All right, so just again, one of the myths that I'm saying, operating energized electrical equipment is not 100% probability of an arc flash occurring. Next, if I go into the electrical room, I need full body arc flash and shock PP worn just to go in. Not true. The door on the electrical room indicates arc flash and shock hazards. I need arc flash and shock PP. Not true. The work task determines the need and based on risk assessment. The equipment label for arc flash and shock is on the electrical equipment. The arc flash boundary is real right now. It's not true. Again, the work task determines the arcing fault probability and if the arc flash boundary would be real or not. Opening hinge door on energized electrical equipment, 100% probability of arcing fault and arc flash. I believe that's not true as well. Yet Z462 and 70E would say that any equipment conditions, arcing fault is yes. So again, we need to use the information in the standard, do our own risk assessments, and determine what work task applies to what equipment when the likelihood of occurrence would be yes. So again, what have you heard? What do you believe and why? So I'm trying to stimulate thought and get you to think about the myths and misinformation with respect to your application of Z462 or 70E into your workplace. Ask questions, get substantiation from the trainer that you've hired or the P.Eng electrical engineer that stamped your incident energy analysis report. Don't necessarily accept what they're saying. Ask them how they are making the decision or how they are telling you what they believe in the training or in their reports that are issued. What is energized electrical work? Are you confused? So I wanted to have the history, sort of the status quo, then have some slides here that really just very quickly, what is energized electrical work? The definition in Z462 and 70 is working on is diagnostics or repair. So those are the two high level, definitions of what working on is, but it's work task specific as identified in Z462 and 70E. They were always work task-based standards, but now we have the tables that has a discrete list of work tasks, and not all those work tasks may apply to every workplace. Operating energized electrical equipment is not working on it. So I also want to emphasize that operating energized electrical equipment isn't maintenance when you're operating the equipment and it's not working on it. The most typical energized work tasks are voltage and current measurements, use of a test instrument, removing a bolt-on cover, opening a hinge door, if we define that as energized electrical work, which 70 and Z462 do, because behind the hinge door is energized conductors and circuit parts. I'm not discounting that, but not all electrical equipment, right, has energized conductors and circuit parts behind it. And if they do, the voltage of them may not be high enough to create an arcing fault. installing a circuit breaker and a panel board, energized, racking and out power circuit breakers, installing temporary protected grounds, disconnecting batteries, or battery testing. So this is just an example of some of the work tasks that are listed in Table 130.5C and NFPA 70E or Z462 Table 2. Again, use that table, condition of maintenance, as any normal or abnormal, and then it advises you of the likely occurrence of an arcing fault or arc flash as yes or no. So energized electrical work is diagnostic troubleshooting, repair and alteration. We want to eliminate the repair and alteration, and we want to sustain the diagnostics and troubleshooting or the work tasks that are related to isolation, racking and out power circuit breakers, and installing temporary protected grounds. So energized electrical work, we need to sustain it. We need to make sure that the risk is acceptable, and we need to make sure that we don't go down a rabbit hole with those myths and misinformation that debilitate us from using electrical energy and having workers that are qualified and competent and trained with qualification training or electrical safety training, understanding this work, and we have the right, again, hierarchy of risk control methods applied to reduce risk to that worker when they do energized electrical work. As far as the normal operating condition requirements, there's 6 normal operating conditions: installed to the code, it's properly maintained, the equipment is operated to the specifications and the equipment manufacturer's requirements, hinge doors are closed and latched, covers are on and bolted, no evidence of impending failure. So this is the definition of normal operating conditions offered to us in 70E and Z462. The maintenance is subjective, right? And that's where I see a lot of comments in industry, well, we don't know about the maintenance. Well, again, if you don't know, then get some information, find out if maintenance has been performed. You know, maintenance reports are typically issued when you have a maintenance and testing consultant or contractor or equipment manufacturer's representative on site doing maintenance work for you. There should be a report issued. There should be evidence of maintenance. There might even, excuse me, depending on the equipment, I have started to see this, there's actually labels being placed on equipment with dates. So again, it's still subjective. We do have the CSA Z463 Maintenance of Electrical Systems Standard for Canada that can provide you with guidance. It is a very good document. Again, I mentioned I was involved in its initial development as a guideline, and when we made it a standard, and it published last August. So again, normal operating conditions, use a risk assessment procedure. I promote a qualitative risk assessment, which is subjective, and that's where you have to be, I guess, reasonable with respect to your subjective determination of likely occurrence. So status quo, what is energized electrical work? We need to ensure we manage the myths and misinformation. We use risk assessment as a valuable tool. And risk assessment, I find that maybe it's misinterpreted. Oh, it's too complicated, we can't do that. Or the electrician's supposed to do the risk assessment. Those are all, again, false statements. Risk assessment, it can be as complicated as you want it to be, or it can be simple as you want it to be. And we don't get the qualified electrical worker to complete this on their own. The employer and the employee work together to do the risk assessments. We can do those risk assessments committee-based against the generic work task descriptions and define the hierarchy of risk control methods that we expect the qualified electrical worker to apply whenever they're doing that specific work task in the field. And then they actually fill out some documentation that advises us that have applied the controls. This would be the job safety planning requirement that's now mandatory. So again, we got to have justification. We want to eliminate energized repair and alteration. That said, if we do have justification, we can use the energized electrical work permit process in 70 or Z462. With justification, we can use the energized electrical work permit. The energized electrical work permit is not required to be used with every energized electrical work task. Unfortunately, this is another myth that I hear, right? So understand when the permit's required, when it's not, what the exemptions are. And in my opinion, in your company's documented electrical safety program, you can actually take additional exemptions that are valid. Don't be confused. Don't get confused. If you are, ask questions of the person giving you the information. Make sure they provide valid substantiation, not fear-based tactics or just because, right? What is the substantiation for the recommendation being made? Use Z462 as a toolbox. Be reasonable and practical in your interpretation of what energized electrical work is and when the worker performing the work task is exposed to arc flash and shock hazards. Do not be overly conservative. Use risk assessment, procedure, and process to make decisions. Manage the residual risk determined by ensuring that the hierarchy of risk control methods is applied by the worker. And all of this is facilitated by developing and implementing an electrical safety program. Based on the poll, we almost had like a 50-50 response that compliant programs are in place. My opinion is I think it's far less than 50% of industry in Canada or the US, right, has a compliant electrical safety program. It actually was 50-50. Thanks, Anthony, for bringing that poll back up. So my opinion is you've really got to step back with managing what energized electrical work is and getting rid of confusion by creating documentation. And then again, within that documentation and your risk assessment processes, make sure you're not overly conservative. Be reasonable. These pictures were and videos were provided to me from Bulwark. I was actually at the Kima lab last week and witnessed arc flashes of clothing. The PP works if it's actually arc rated and if we ensure that we don't have 100% synthetic or cotton polyester blends underneath, because that clothing will melt. So on the left, the slide will show you that as well. When we get this arc flash, it's a wave. The instant energy is a wave. You can see the back of that arc rated shirt wasn't impacted. It was the front that took the instant energy and would save you from being burned beyond the 50% probability of the secondary burn injury. On the right, that's Scott pointing at the synthetic shirt that melted to the mannequin underneath. So it's really important, again, that we get the PPE, but the PPE works if it's used properly. This is actually an arc-rated face shield on the left, and in the middle it's been arc flashed. What's interesting is this is a pass. Now you're going to go, wow. Well, it passed because it in fact the LED didn't even get impacted negatively. But again, this would be a pass. This shield's been rated for 17 calories per centimeter squared. So the worker's face with a balaclava on behind would achieve 50% probability of the onset of a secondary burn injury at 17 ATPV. Arc flash suit hoods on the left on a test apparatus at this is at the Connectrix lab. These are 140 cal arc flash suits, and on the right, when they've received, and this is a significant instant energy. We're talking 140 cals of exposure, so it does significant outer layer damage. But again, the worker underneath, when arc flashed at 140 cals, would have the 50% probability of the onset of a secondary burn injury. Manage the change related to everything that you've done. So again, the standards are evolving. The good thing is the change that you have to manage related to them will slow down in the 2020 first editions of 70 and Z462. We might see the arc flash P category table method evolving. We'll see. But again, the good news is the change related to the standards and the management of change to your policies and practices would be limited, right? So I recommend that we have management of change related to your electrical safety program, and it needs to be reviewed and updated. It should be audited annually, right? And every 3 years, that program needs to be updated based on the changes to the applicable standards. Single line diagrams and key schematics. This is an ongoing challenge. I don't know how we're ever going to get that one solved, but we really need these drawings to be developed, specifically the single line diagrams. Once they're developed, we need them to be maintained. Arc flash and shock equipment labels, if you do change your labels, they need to be MOC'd, right? And I encourage you to look at the labels you've installed and make sure they're compliant labels. Training, at least every 3 years, aligned with the Z462 changes. So you do have to manage that change, and training should be approved when the standards change. Arc flash PP evolution to the true color gray lens, LEDs, hood ventilation system upgrades required, right? So there's two concepts here I'm sort of communicating with management change. You should evolve with change, plus we want to make sure that we have specific approvals of some of these changes as well. The last point on this slide is the IEEE 1584 2018 edition. Do not panic. You do not immediately have to review your existing studies and update them. Ensure you understand and control any of the changes, any of the information that's provided to you by the consulting engineer that will be contacting you to advise you that you have to update the study. You do not need to completely redo your existing study. Most significant impact will be the horizontal conductor in a box electrode configuration, and conservative assessment, because the incident energy could go up as much as 200%. So manage change throughout this journey that we're all on, and I hope that we continue down this path. But I'm encouraging you to ensure that you have documentation in place, you ask and get answers that can be substantiated by the person that you're asking the question to. Now, lastly, the future. So in Canada, again, the last 12 years, we've seen significant evolution. And the evolution has also been in equipment design and what we've been able to procure from equipment manufacturers. So I see prevention through design continuing to evolve. The challenge is we have a lot of legacy electrical equipment, and the evolution of replacing that equipment with new equipment with prevention through design and inherent, 100% inherent in it, is going to be a long time out there in the future. So we'll never be able to completely eliminate energized electrical diagnostic and troubleshooting work as well. I still believe there'll be some level of that no matter how the designs evolve. Again, there is personal electrical safety devices that are currently available, so we move everything to outside. So again, there's some challenges and discussion there. Isolation work task, racking in out power circuit breakers, automated on low and high voltage switchgear. So built-in racking into the switchgear, that's evolving now. So that's an area where I think we could fully automate that. Again, we still have to question if the automation fails, do we have competency with the qualified electrical work to do manual racking? Installing protective grounds. Again, when we do full isolations, can we completely automate the installation of temporary protective grounds on enclosed equipment? I don't think so. Overhead systems, probably never, right? So this is the other aspect. I haven't talked a lot about utility and utility work practices, so that's a whole other discussion. More frequent specific electrical equipment maintenance, that has to be the future. Again, that'll help with, again, some of the issues where workers are concerned that, their equipment's going to arc flash imminently, the whole discussion of operating energized electrical equipment as well. So more frequent and focused maintenance as well. Again, I started with some history about identifying the hazards and how that has evolved. We didn't identify the hazards. I talked about, shock being a higher priority than arc flash because of the frequency of exposure. Again, the consequences are significant as far as injury and or fatal injury, electrocution for shock and burn injury for arc flash. The OSHA and OH&S regulations in North America have evolved, and in Canada specifically, we're seeing content has been added unique to electrical safety and arc flash and shock hazards, but it's still not 100% clear, and arc flash is really not identified specifically in most provinces. Electrical incident statistics prove that the majority of the incidents are shocks and electrocutions, and we do have arc flash burns and burn fatalities occurring as well, but thankfully at a significantly lower frequency than the shocks and electrocutions. But all of those statistics aren't good statistics. I'd like those statistics to be driven down to 0 if possible, but again, I don't think that's necessarily achievable. The Z462 and 70 standards provide a basis for due diligence to these regulations when an electrical safety program is developed, utilized, and audited. The key is getting an electrical safety program in place will help with a lot of the myths and misinformation, with a lot of the confusion about what energized electrical work is and isn't, with that documentation in place and training your workers on that specific requirements of that document. So arc flash and shock PP is readily available. We're having an evolution in that PP, true color gray lenses for the shields and hoods, the applications of LEDs, and the hood ventilation systems, again, are evolving and readily available. The IEEE 1584 2018 edition needs to be managed. Do not be conservative. Do not panic. Make sure you ask for substantiation from the professional engineer that's going to say he needs to do the study, he or she needs to do this, to redo the entire study, or this information, or this is why we're going with this box electrode configuration. And if you're uncertain, ask for a third-party opinion with respect to some of the recommendations being made to you. We need to manage the misinformation and myths. It's going to take us down a rabbit hole in industry, and we don't want to go down that path. Working energized and the risk related to it can be managed where the risk residually is as low as reasonably practical and the worker can proceed. If we continue with the misinformation, it's going to actually contribute to increasing the likelihood of occurrence, because we're going to get qualified electrical workers that lose confidence, and they're going to have a human performance problem with human error probability going up. Not good. So understand what energized electrical work tasks are and what when a worker is exposed. Operating energized electrical equipment is not maintenance. Under normal operating conditions, no arc flash PP is required. I know there's a lot of people out there that will not agree with me on that point, and I'd love to talk to them about it. Arc flash PP works if worn and worn correctly. Management changes required. The future will see improvements in electrical equipment design and engineering prevention through design.
Thank you, Terry, and thanks to everyone who came for attending and supporting this presentation. Reach out to him with any other questions you may have of anything he covered. You can visit ebmag.com/webinars for recordings of all our past education sessions and any upcoming ones we may have. And with that, again, thank you, Terry. Thanks to all of you. I wish all of you an excellent day.